Okay. Oh, yeah. This is, you can read this, how to do well. Um, like I said, you can do this two routes. Either do the work or cheat and not get caught. Right? Okay. Got that. Okay. I forget what the joke was on that. Probably about people who weren't paying attention in class or something like that, and why they're not going to do well. But anyway, this. Let's see, where is that? Oh, here we go. Good. Okay. Anybody? What is science? Anybody? I don't care. Oh, by the way, I don't care if you're right or wrong. I really don't. Sometimes it's better to be wrong. By the way, when I went back to school, after being a film editor, I didn't know much, and I knew I didn't know much. But I quickly learned that most of the other students didn't know much either, and they had stayed that way by not asking any questions, because they didn't want to look stupid, especially when I got into grad school. I knew more then, but I still didn't know very much. And so people just went along thinking they knew stuff, but they didn't, because they didn't ask any questions because they were worried about, whether they looked smart or not. And it gets worse and worse the further along in school you get, until you're finally going for a PhD or becoming a physician, something like that. No one wants to look dumb, but it's actually, if you actually raise your hand and say, I don't understand, usually the thing that confuses you is the same thing that's confusing everybody else, but they've been too afraid to ask. So, since I was not bashful, I stuck my hand up all the time and asked really stupid questions. And it turns out everybody else in the class was wondering those same things, and they had been for the last couple of years. So they learned something inadvertently from me, because I just didn't know. And in fact, that's why you actually do science, by the way, to figure out things. Okay, but anyway, I want a definition. Anybody, a definition of science? Okay. Yeah.
A study of a topic or something like that.
Okay. Oh, come on. Yeah, okay. Oh, I know. In particular, anything?
Honestly, because I feel like there's so many different types of science and fields.
Okay. How about just the natural study of the universe, of the natural world? Okay. Okay. Now, that's actually, what that is not a definition of science. It's a definition, one of the reasons why we might want to do science. Just try to figure out what the hell's going on all around us. There's different ways of of knowledge, of gaining knowledge. It's called this epistemology. We've got the humanities. We've got art. We've got business, let's say, learning specific things that you get good at that you can, let's say, make money. A lot of the reasons we do gain knowledge is for practical reasons, right? But science itself is not really about gaining facts. Science is actually just a process. That's all it is. Scientific okay, scientific method. So science really is all it is a process. It's not one of the reasons we do it is to find out about things, a reliable way of finding out about things in the universe, but it's not just about gaining facts. It's a way to understand things. And like I said, in science we never prove anything. We just say something is more likely than another. And we do that by the scientific method. Now most people, it says here, a systematic enterprise. That means kind of with rigor, doing things in a certain framework, not just all over the place. That an enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. Now, the important part of that testable explanations and predictions. Okay? Now, that's part of the scientific method. You probably think about science in terms of doing experiments. And that's one thing that we do in science. But sometimes, actually, you can't do experiments. Like in evolution, you can do some experiments, but you can't really do long-term. Like, we're on this earth, it's an incredibly short period of time. We basically usually do not get a chance to see any major changes that happen during the Earth's history. The Earth was formed along with the other planets 4.5 billion years ago. It's a number you can't even imagine. We can't even imagine 1,000 years, and yet 1,000 years in geological time is a blink. So there's a lot of things that we would like to do as scientists that we can't. Like, we make predictions in terms of evolution about evolution by natural selection, things, organisms, populations evolve in response to their environment and how the environment changes. The environment is a big thing. It's abiotic, temperature, air, the amount of light, all that kind of stuff, and biotic. All the other organisms that are living. And in fact, probably the most important environment for you guys right now is a social environment. Well, for most humans. We have to navigate all kinds of things as we're growing up and then becoming adults. And it's mainly has to do with reading other people and knowing who you can rely on and who you can't. So, like, now I know that I have a friend in here named Pat, right? You might want to talk to him afterwards. He might be your friend too. Now, but we can't, let's say, one cool experiment would be to take the Earth, run it back in time, and then watch it go forward in time. And we would make predictions about how life might evolve. Not specifically that there would be dinosaurs or at the end there'd be humans or anything like that. Just in terms of what evolution by natural selection predicts in terms of theoretical stuff. It would be really cool to do that, but we can't. So we're kind of stuck. Also, we wouldn't do just one Earth. We'd probably replicate it about 1,000 times. We take 1,000 Earths, make it everything identical, and then there's always a bit of stochastic or random things going on, and see if all the different Earths wouldn't evolve the same things in time, but they would show evolution that might all share similar features. So that would be a neat experiment to do. But we can't always do experiments. So the process, the scientific method, is usually a way of thinking more than anything. And everybody wants to know if they're right or not. And we have what's called beliefs. Yeah, let's get back to that. Beliefs are kind of a shortcut about the knowledge of the universe. It doesn't mean that they're right or wrong. They're beliefs, but they're usually unsubstantiated. Now, doing science is not like a belief. With science, you actually have some idea about whether you're more right or less right. So you come up with, let's say you see something. The sun rises in the morning, goes across the sky, and sets. And you think, why? And then the moon does it, and the stars come out, right? The whole bit. People wonder why it happens, and people have been wondering that for a long, long time. Now remember, there was a point where everybody who was living from that time and before believed that the Earth was the center of the universe. In fact, it's completely understandable. If you didn't know better, you would say, oh yeah, yep, we're the center of the universe, everything seems to revolve around us. Our intuition would tell us that. Now, but a scientist would say, okay, well that's a hypothesis. Is that really the case? Now we know it's not. So we have to test these things, but we can do it just thinking about it, or we can do it by running experiments. Sometimes we can't. So I'll give you an example, another one. It's pretty good. The scientific method, right? Gravity. How come we don't fly off into space? By the way, that's what Newton, the guy who first came up with the law of gravity, asked. He was asking, why does the apple fall to the ground? He wasn't asking that. He was asking, why does the apple not fly off any other old way? So that's where he got his first idea. But let's say, okay, boom, gravity. Okay, so why does this happen? Once upon a time in California, you know how we're full of crazy cults? People believe all sorts of crazy stuff. There were some people who believed that there were these people in the center. The earth was hollow, and people were actually living inside the earth. It wasn't all rock and an iron core and all that. And that these people actually had metal heads, and that because of that, things stayed on the ground. Right? Boom. Okay. You say that, okay. That's a valid hypothesis, explanation, isn't it? It's a matter of, can we test it or not? Can we actually test that hypothesis? Well, we could, drill in to the earth. But we wouldn't even need to do that, actually. All we really have to do is, okay, what are these keys made of? Metal, okay? Now, if it's true that everything stays on the ground because of these metal-headed people at the center of the earth, then the prediction is only metal should stay on the ground, everything else should fly up. We just disproved that prediction. So, now there may still be people at the center of the earth. We haven't really answered that question. But we can certainly say that gravity is not because of people with metal heads or anything else in the center of the universe, because if it was metallic, it would be only affecting metal and not other things. What we've done is we've falsified a prediction. Now that's all that science really does. Now I'm going to leave you with that. That's where we'll pick up. But we don't go around proving stuff. We go around actually disproving stuff like I just did.